There are many different reasons an NPC may want to find a path between two places. It may be trying to attack an enemy, or get out of the player's way, or follow something, or perform some kind of scripted movement. In any case, requests into the pathfinding system boil down to a starting position and an ending position. Movement starts with finding if a path between two places is clear, and how it determines that depends on what kinds of movement the NPC can do. There are 4 kinds of movement: moving on the ground, jumping, flying, and climbing. There are also types defined for swimming and crawling, but nothing uses them. Crawling has no code written for it at all, and the only code for swimming states that it would find if its path is clear identically to how flying does, which is really not saying much. Ground movement begins firstly by automatically failing if the distance between the start and end point is over 600 units. You'll see as we go on that we're about to do some relatively intensive work which only gets worse with more distance. We're going to have to front load a lot of information, starting with the floor point check. The floor point check is a basic check to make sure a position is valid. A 2-dimensional square-shaped trace is done starting from 18 units above the position and going 738 units down. The dimensions of the square are taken from the NPC's hole. A hole is a box that acts as an NPC's hitbox for most purposes aside from bullets. You may recall a more vintage time period where I said that line traces that start inside solid material will keep going through that material until they reach empty space for the first time. Well, this isn't a line trace, it's a hole trace. A hole trace will stop instantly if it starts inside something solid. If the trace starts inside something, it will try the trace again, but without starting at 18 units above the position. If the second trace is still starting inside something solid, the entity hit by the first trace is either a physics object or an NPC, and the position of the check is where the NPC currently is, the check will pass. This means something is inside the NPC, and hopefully the issue will fix itself. If the second trace started inside something solid and the first trace did not meet those very specific conditions, or either trace never hit anything, the check fails. Otherwise, the check passes, which indicates the position has some kind of ground under it within a certain distance, and the position is not embedded inside anything bad. The floor point check lets us be sure of exactly where the ground actually is, since there's a chance the initial start and end positions we were using were in the air and that would just cause issues. A floor point check is done for the starting position and ending position both. The points on the ground that the traces in the checks reach are regarded as the actual start and end positions for the ground move test, unless neither trace hit anything or the second trace started inside something solid, in which case the position used is simply the initial position of the given check. The floor point check on the ending position does not need to be passed, but the starting position one does. The ground move test runs a step check at intervals along a path from the start to the end. The step check is similar in concept to the floor point check, but is much more robust, so I will finish talking about the ground move test first. The step check is run once every 16 units along the path. If the first check comes back and it was found to have a physics object or NPC blocking its trace, it will try again while having that object set to be ignored by the trace. It will try the check over and over until it has made 16 attempts, with the final attempt ignoring 15 objects. Past that point, it will give up. It will always give up immediately upon being blocked by something that is neither a physics object nor NPC. Only the first position the step check is done in will be retried in this manner. Every other one will accept failure immediately. The passing of the ground move test depends on all of the step checks along the path passing. If there was a certain object associated with the navigation query and the ground move test fails because it was blocked by said object, this still counts as a successful query because that means the goal was reached. This exception also applies in the case that the target is inside a vehicle and the hit object was that vehicle. The step check is like a more sophisticated floor point check. It works by tracing an NPC-size hole from a position to a certain point in the direction of the goal position. Usually the ending point of the trace will be 16 units away, but if the goal position is less than 16 units away from the step check's position, it will only trace out far enough to reach the goal. If the trace started inside something solid, it will move the trace 18 units up. The only way this can happen is if something is stuck in an NPC higher up than 18 units, since everything below would have already been found by the floor point check or the previous step check. If the trace did not start inside something solid, but rather hit something after starting the trace, it will do a trace starting at the original position and going 18 units up. Wherever that trace lands will be used as a new starting position for the rest of the step. 18 units is the maximum height an NPC can step up or down without any assistance. This is what will allow NPCs to climb up small obstacles and stairs. The important thing is the trace gets done again higher up, where it might now be free of an obstruction. If so, then it goes into a weird and complicated block of code which is concerned with ensuring that the place the trace hit at is far enough away from the start of the trace in order to qualify as a step. I don't know if I understand the idea behind that. I've tried filling with this code for quite a bit and it doesn't seem to have any actual impact on how NPCs move, so I won't go into it too much. If a trace that moves in the direction of the path for the minimum distance needed to qualify as a step hits something, the step check fails. If the raised up trace did still start inside something, then the step check ends here in a failure. If the raised up trace did not start inside something but only moved a very small amount, specifically only up to 1% of the step's distance, or it didn't move far enough to qualify as a step, the trace is regarded as not useful, but the step check does not fail yet. Otherwise, the raised up trace is regarded as the original trace for all purposes here on out. This ends the section of code that handles the first trace being obstructed. We've now determined that the space along the step is not obstructed, but a lack of obstructions does not mean the step can in fact be taken. Another trace is done where the first trace ended at, going 18 units downward. This should hit the ground. If it does not, then there's a difference in height too great to step down to. The ground is no longer walkable, so the step check ends in a failure. If the object the trace hit is something that is flagged as not being allowed to be walked on, the step check fails unless the NPC is already standing on that thing. Some models have a flag on them to say that NPCs should not walk on them. A quick example of something that has this flag would be this chair. If an NPC were to step onto this, they would probably have some issues. The next set of conditions the trace has to meet are strange. If the trace landed at least 9 units higher than the step check's starting position, the object the trace hit is one of these things, and the angle of the surface the trace hit is pointing upwards within a tolerance that would be suitable for standing on, the step check fails. This code almost never gets triggered and I don't really know why it's there. The final test for the step check is the stand check. That's right, there are checks within checks. The purpose of the stand check is to prevent NPCs from standing right on or mostly off ledges, which looks unrealistic. All of the traces in this check take the NPC's hole at half the width and divide it into 4 separate traces. The holes have no height. The holes will start from where the last trace of the step check hit and go 18 units down. First, the southwest quadrant is traced. If it hits something and that thing is not flagged as something that can't be stood on, as was discussed earlier, it then traces the northeast quadrant. If that trace found suitable ground as well, the check passes. If either trace did not find suitable ground, the same process is done using the northwest and southeast quadrants. If those traces both found suitable ground, then the check passes, otherwise the check fails. If the stand check passes, the step check passes. If ground movement doesn't work out, the NPC may try jumping next, if it's allowed to. Jumping movement starts by doing some simple math to see if it should be physically possible for the NPC in question to jump how it wants to. Every NPC has 3 numbers it refers to for this. The maximum jump rise ensures the end point of a jump is not too far above the starting point. The maximum jump drop ensures the end point of a jump is not too far below the starting point. It is ensured that a jump is not too tall by seeing if the end point is not more than the maximum jump rise distance plus 25% above the starting point. That sounds redundant in regards to the first height check, but you'll see what this is for later. Finally, the distance between the start and end point with consideration to all 3 dimensions must be smaller than the maximum jump distance. I guess we can talk about the numbers that every NPC uses. First of all, I need to clear up a misconception I had that made it into a different video. There are actually only 3 NPCs with the native ability to jump. Those are hunters, antlions, and fast zombies. Hunters and fast zombies have a maximum jump rise of 220 units, 512 distance, and 384 drop. Antlions have 512 rise and drop and 1024 distance. Every other instance of jumping is an edge case that was done using tools we'll go over in the future. The numbers that all other NPCs use when figuring out their jumps are 80 rise, 250 distance, and 192 drop. There are 3 NPCs with their own special behavior at this point in code as well. Hunters do a stationary hole trace on the starting position to make sure the jump doesn't start in anything solid. A little random, but okay. Antlions make sure they don't jump into a place they don't like, such as into a thumper's area of influence. Antlions also refuse to make jumps that end less than 128 units away from their current position. Antlions will also do a stationary hole trace on the ending position, and if the trace hits another antlion, that antlion will be told to move out of the way if it's not busy. Father Grigori is not allowed to jump upwards under any circumstances, only downward or to a place of the same elevation. This effectively just means he has a maximum jump rise of 0. Like with ground movement, the start and end positions both have floor point used on them, and the places where those checks hit are used as the real starting and end positions from this point onward. A stand check at the end position must be passed. The NPC does not want to spend more time than necessary jumping, so it will try to take the fastest and lowest arc it can manage. This is easily the most technical and particular code I've ever covered on my channel, and it's really not possible to summarize nicely, so pardon my French. A very quick note on source engine vectors: these are not your standard C++ vectors. These are trios of floats. Now would also be a good time to say that speed and velocity in source are measured in units per second. The final result of the operation is going to be a velocity vector that the NPC will remember to apply to itself when it wants to jump. This means gravity is going to matter. The force of gravity will at all times be represented as either a straight upward vector or that vector's z-value. The z-value of that vector will be the console variable SV gravity times the NPC's gravity multiplier if it has one. SV gravity is set to 600 in Half-Life 2, which means objects accelerate downward at 600 units per second squared. This number is not realistic at all, but oh well. Some NPCs have a multiplier for their gravity when jumping. Alex in the episodes, citizens and combine soldiers use 1.8 and hunters use 3. Another factor will be the NPC's built-in maximum jumping speed. For antlions this is 1024, and for everyone else it's 350. Then there are some other variables that get defined at this point in code, though some are not immediately relevant, but I think it would be best for clarity's sake to mention them now. Minimum successful jump height and minimum jump step are initialized with the value 1024. Minimum jump height is 0. Then there's a vector declared which is going to represent the apex of the jump. Then there's the vector raw jump velocity, which will be set to the value returned from the function calcJumpLaunchVelocity. This function works off of 6 parameters: the starting position, the end position, the force of gravity, a minimum height, the maximum jumping speed, and the apex vector. Every time this function is called, all of these parameters use the same variables except for one case which we'll talk about later. Also, the minimum height and apex vector are actually pointers to those variables, which means the changes made to those variables by the function will be remembered after the function has finished executing so that they can be used for other things. Okay, with all of that out of the way, we can finally get to the math. First, the rise and run of the jump are found. The rise is found by looking at the heights of the start and end positions. The run is found using the Pythagorean theorem. The minimum horizontal time is the run over the maximum jumping speed. The minimum horizontal height is half of gravity times half of the minimum horizontal time squared. This seems weird at first, but this number represents the bare minimum height needed to travel the distance of the run when moving at the maximum jumping speed, which is the ideal speed to move at. This will only make sense when the rise is non-positive. A nicer way to write this would be gravity times time squared over 8. Then the game looks at the minimum height which was passed into the function, the minimum horizontal height, and the jump's rise. Whichever is the highest is the new minimum height. Now the game finds the time it will take to complete the jump. T0 is the square root of 2 times the minimum height over gravity. This represents the time it takes to go from the starting position to the apex of the jump. T1 is the square root of 2 times the absolute value of the minimum height minus the rise over gravity. This represents the time it takes to go from the apex to the end position. The final horizontal speed is the run over T0 plus T1. Since this is a 3D engine though, there are 2 horizontal axes, and currently our horizontal speed doesn't tell which direction the NPC should move in along those axes. To do that, the game keeps a direction vector which is equal to the end position minus the start position, zeroes out its z value, and normalizes it. Normalizing a vector means you shorten or lengthen it until its length is 1 unit while keeping it pointing in the same direction. To make our speed and direction into a velocity, we simply multiply them together. The final vertical speed is the square root of 2 times gravity times the minimum height. The apex vector, which has not mattered at all until now, is the starting position plus the direction vector times the horizontal speed times t0, which represents where we would be horizontally after t0 seconds of moving, plus minimum height units in the z-axis. Finally, the jump velocity vector is returned. So to summarize, calc jump launch velocity tells us the direction and speed to jump at, the minimum amount of height needed to complete the jump, and the apex of that jump. When the function returns, its value is stored in a vector called raw jump velocity, and a variable called baseline jump height is set to the value of the minimum jump height, which has been changed by calc jump launch velocity as we talked about earlier. One problem: our old friend obstructions. Hopefully we can just jump over any obstacles we find, but we don't want to waste time jumping for longer than necessary, so we still need to take as low of an arc as we can manage. Imagine a person says they're thinking of a number between 1 and 8, but when you guess numbers, they don't actually tell you if you're right, only that you're wrong when your guesses are between certain ranges which you also don't know. Valve's code starts at 1. If that's wrong, it jumps up 4 places, which is half of 8. Let's say that's not wrong. It tries again 2 places down, which is half of 4. Let's say that's wrong. Based on certain factors that don't fit well into this analogy, it will try again either up or down by 1 place, which is half of 2. The important thing here is that we always try new numbers that are at the halfway points between numbers that we've already tried. This is called a binary search, and it's the most efficient way to solve our problem. The code goes into a do-while loop. This is a relatively niche kind of loop where the code block is run first, then if the condition at the bottom evaluates to true, it runs again until the condition comes back false. The loop starts by calling calc jump launch velocity again and storing the vector in raw jump velocity. On our first time through this loop, nothing has meaningfully changed, so this is redundant, but oh well. Okay, remember a long time ago when we were talking about ensuring jumps are physically possible, and this is done by referring to 3 numbers, the maximum rise, distance, and fall? That was a function called isJumpLegal. Based on how I described it earlier, you would think this function was only looking at 2 positions, the start and the end, but there's actually a third, the apex. The first time this function got called, the code passed in the end position as both the apex vector and the end position vector because there wasn't an apex vector found at that time. Now that there is one, it's passed into the function this time, and it behaves slightly differently. Remember that third check it did, which seemed redundant? That's what the apex vector is for. If the apex is more than the maximum jump rise plus 25% above the starting point, then the jump rises up too much. If the jump is not legal, then the minimum jump step is divided by 2 and the minimum jump height has the minimum jump step subtracted from it. Recall that the minimum jump step was defined as 1024 all the way back before the first call to calc jump launch velocity. A jump not being legal always means the NPC should try a lower arc. The entire remainder of the loop is only run when the jump is legal. Now we trace along our path, just like every other mode of movement, except our path is not a straight line anymore, so what we do is divide the trace into multiple parts to get a rough outline of the arc. First we find how long 1/10 of the jump will take, which we do by dividing the run of the jump by the magnitude of the horizontal component of raw jump velocity and then dividing that by 10. We'll call this the time step. The next place to trace to is always found by taking the starting position or the place the last trace stopped at and adding raw jump velocity minus half of gravity as a vector times the time step and then times the time step again. The arc is traced in 10 segments. If any trace hits something and the surface that was hit is facing downward, even by a tiny bit, the surface is interpreted as a ceiling and the game divides the minimum jump step by 2 and the minimum jump height has the minimum jump step subtracted from it, just like earlier. If the surface is not facing downward, however, the NPC should try a higher arc instead, so in this case, the minimum jump step is added to the minimum jump height instead. If the trace in question did not hit anything, then raw jump velocity has gravity as a vector times the time step subtracted from it, and then it goes on to the next trace. This is to simulate how the direction of motion changes over time from gravity accelerating the NPC downward. If all of the traces come back good, then the minimum jump height is remembered in a separate variable called the minimum successful jump height, which was first mentioned and defined a long time ago, and the NPC again tries a lower arc. Recall that all of this code takes place inside a do-while loop. Now it's time to check the conditions of the loop, and if they're all true, the loop will run again until one of them is false. The three conditions are these. The first condition is that the minimum jump height must be greater than the baseline jump height. Remember the baseline jump height? That was set to what the minimum jump height was all the way back immediately after the first call to calc jump launch velocity, and in that call we were looking at what would be the ideal arc before accounting for obstructions. If the minimum jump height is less than or equal to the baseline jump height at this point in code, that means the code was going to try an arc lower than the perfectly ideal fastest and lowest possible arc, which means that arc is either not legal or blocked by a ceiling, which means it is very likely the case that no arc is possible, or that arc is actually free of obstructions. Upon learning either of those things, there's no longer a point in staying in the loop. The second condition is that the minimum jump height must be less than or equal to 1024. If it's greater than that, then the jump's arc, if a clear path even exists, is too high to make. The third condition is that the minimum jump step must be greater than or equal to 16. Below this point, we'd be testing arcs that are almost the exact same, so this is here to define a reasonable margin of error and ensure the game doesn't waste too much time on this code. That's the end of the do-while loop, and we're almost done. If the minimum successful jump height is not 1024, the jump is deemed possible. However, since our traces were modifying the raw jump velocity vector to account for gravity across the course of the jump, that vector no longer represents the velocity the NPC actually needs to apply to itself when doing the jump for real. So calc jump launch velocity is called one more time, but with the minimum height being the minimum successful jump height instead of the minimum jump height, since that variable has also been changed to a value which is no longer useful. Yes, this is inefficient. If the minimum successful jump height was 1024, then we never found a suitable arc, so the jump cannot work out. It's notable that jumping is the only movement mode that does not let the NPC collide with its target entity. Flying and climbing are both very similar. It's a simple hold trace from the start position to the end position. You'll notice that climbing does not trace its entire path all at once. This will be explained in the future. The code for finding if an NPC can go along a given single segment path is called the NPC's move probe. In most cases, an NPC has now determined if it can move from point A to point B. In the case we can't take that path, there is another option if the NPC is trying to move on the ground or fly. The NPC looks at the direction of the path and where the blocking object is and produces vectors that are to the left and right of where the path got blocked. Flying NPCs will also produce vectors for above and below the blocking object. The distance of these vectors from the original path is not based on the size of the blocking object. The lateral ones are half the NPC's whole width to the left and right, and the vertical ones are 1.5 times the NPC's whole height above and below. The distances would ideally be based on the size of the object, but the move probe could be blocked by something that's a static part of the map, which would mean there's no appropriate size to regard the blocker as, because that thing is essentially the Earth. The NPC uses its move probe to trace out to those points one at a time. If any given path is good, then it traces again from that position to the end position. If a path is bad, it tries using another point until all 2 or 4 have been tried. If the entire thing is good, then that means the NPC can simply sidestep whatever is in its way. To do this, the NPC uses a multi-point path, but we'll talk more about that in the future. If none of the move probe checks come back good, the NPC will try again with points that are another step away from the original path. If the path from the start to the new point is not suitable, regardless of if the path from the new point to the end is suitable, on one of the closer set of checks, the corresponding farther out move probe check will pull its point towards the start by half a hole width. Remember near the start of the video when I said that ground movement automatically fails if the distance between the start and end point is over 600 units to avoid doing too much tracing work? That idea still applies. If the NPC is moving on the ground and the original path is over 384 units long, we'll save some tracing calls by substituting the endpoint with a different point closer to the obstruction, then once we're past it, we can continue on the original path. Problem is, the substitute point is the direction of travel times 384, plus nothing. This means the NPC's traces go to 384 units in the direction of travel away from the map origin, which means the triangulation code almost always fails for paths longer than 384 units. Oh, Valve. Failing that, there's one last thing an NPC can try. If the NPC is moving on the ground or flying and the path is blocked by an NPC, it uses the move probe one last time on the original path, but while allowing all of its traces to go through NPCs. If this check comes back positive and the NPC that was blocking the way is friendly or neutral to the original NPC, the NPC will consider the path valid, and later on, that other NPC will be told to move out of the way. This is local navigation, and it can do some nice things for us, but it's obviously not going to take care of every navigation need an NPC has. We can go from point A to point B, and that's it. Our ability to move around obstructions only extends about one pace away from straightforward, if it even works. We're really not even equipped to move through the average building. Now, sure, we could perhaps extend our triangulation abilities out further, but that can only carry us so far. Plus, all of this tracing is really expensive. Are we really going to do all of this all the time for every NPC? Something more is needed.